All right, guys, we're going to go ahead and get started. So if you take a seat. Cool. So I see a couple of new faces. Those of you that are new, this is a new setup. We haven't had it this way before. I don't think I like it very much, so we're probably not going to do it again. We usually have tables so you can put your machine on it and follow along and stuff. But apologies for that, I guess. Actually, who is new? Just so I can get a sense. Awesome. Who of you is new to JavaScript in general? A couple? Awesome, cool. Well, we're very beginner friendly. I think this content probably will be. Sometimes things get pretty advanced, but the crowd is always happy to help beginners. So glad to see you guys here. I don't really have any announcements other than we have the next 2 months scheduled, but after that we're open. So if you have a presentation you want to give, shoot me a message on Meetup and we can get on the calendar. Next month is about CAN.js, which I have not used before, so I'm kind of looking forward to. And then after that, it's on the calendar. I think it's confirmed. If it changes, don't get mad at me, but we're going to do a film screening in collaboration with Girl Develop It, Indy. So all the details are on the Meetup page. I think that's going to be pretty cool. A good discussion about, hopefully a good discussion about women in technology. So I have nothing else. Hi, you ready to go? Yep. All right. Yeah.
Hi, how's it going? Where do we go? No, that was there. Okay, so welcome to Indy.js presentation of ES7 Async await feature. I'm Nguyen. I work here at Salesforce as a UI engineer, more commonly referred to as just a code monkey. I love to code. I practically just eat, sleep, and code. That's it. So much like our McCall friend here, who also can eat and sleep. So I want to tell you a story. It's the story of asynchronicity, and it goes something like this. In the beginning, there was linearity, and it was good. The linear flow is predictable, easy to understand, and easy to reason about. Even if you've never seen this login function before or haven't seen it in 6 months, you should be able to understand what it does based on naming clues and the flow of logic. The flow of the login function is simple. Get the user, get his or her authentication, then get the meetup profile, and then attach. Simple. Things are always executed in this order, no matter what. And it executes very fast. Then came along I/O operations and page requests and writes the database, reads from database. And due to hardware limitation as well as technological advances, these operations were generally slow. And it slowed down our applications, or locked it up, or even worse, crashed it. To which the users were mad. Our programs were seen as poor performance, having quality issues, and provided a bad user experience. Then there were callbacks, like so. To simulate a time-consuming operation, like an I/O operation, I will be using timeouts a lot here. I am simulating that the getUser function takes 2 seconds to complete. After completion, getUser will invoke a callback, ta-da, which will then transfer control back into login and completes the rest of login. Simple. The result is the same, except one minor detail. The result isn't available until 2 seconds later. And what you don't see within that 2 seconds is that our app can be doing other things because it's not locked down by any time-consuming tasks like get user. One small note, though, I want to make is that every time I introduce callbacks to newbies and new programmers, they always get tripped up on the flow of logic. They seem to have no problem with the linearity. But some of you here already know callbacks and have no trouble. But for some reason, people without prior knowledge of asynchronous programming, or even those that only knew multi-threading, get tripped up on the flow. The initial flow looks like this. And then after the callback is invoked, the linearity has been broken a little bit. But it's just two paths. It's just this path or that path. This divergence in path somehow confuses my newbies. Not sure why, but they get used to it. So anyway, callbacks are here to stay. Our apps were, again, responsive. They provided a good user experience. The users were happy. Then the app grew, and it grew. Then came callback hell. It was bad. It was bad. It was very bad. Got to the point where I couldn't even reason through and my eyes were just crossed. So to solve this problem, we created promises. Promises were meant to solve some of the problems of callbacks. To use them, it's fairly simple. You just take a time-consuming function like this, and you wrap it in a new instant of a promise, and then return that promise. You then have to let the promise know when the blocking operation is done, and you do that with resolve and reject. Here in my example, I only need to resolve, but the whole idea is that you create a promise, you give it a work function inside the promise to do. Once this work function is done, you have to tell the promise again, hey, I'm done. Very simple. One little small tweak, and there you have it. This is the usual form I construct my asynchronous functions. In fact, all my asynchronous functions look very similar. After creating a few of these functions, using them is a cinch. I utilize the built-in then method to handle all the promise data that gets resolved coming back. So my chaining would look something like this. To handle errors, promise have some kind of a catch implementation. You can handle errors in one of these ways on a rejected handler that can be added to the second parameter of the then function. Or a more verbose way would be just attach a catch function. Just like so. Now, you definitely can understand, you can definitely understand the next part without a full understanding of promises. In my experience, though, if you have never used promises before, it can be difficult and confusing to master. So I suggest we try to understand promises before moving on. A promise is really just a state machine. It has an internal variable indicating the current state of the promise. Most of the promise implementation have these three states: pending, fulfilled, reject. I spelled rejected right. Okay. Let's check. A pending state means the asynchronous operation is not yet done, so a promise value is not yet available. Fulfill means the asynchronous operation is done and there is a valid value. And then a reject could also mean could mean an error, and the value usually holds the reason why that error has occurred. The value of a promise simply just holds the result of the asynchronous operation. That's all it's intended for. And the third piece of a promise is a set of callbacks. These callbacks are invoked when the asynchronous operations are done. The callbacks are also utilized by all these public methods. These are the common three. There's more, but these are the common three that I will show to you tonight. So this is a simplified model of what the promise state machine looks like. And with this model, let's go ahead and create our own promise, shall we? Because why not? I mean, there's plenty of implementations out there. Another one won't hurt. Okay? That's right. Here's the start of my promise, in which I've aptly named High Promise. It's my promise. You can name yours whatever you want. So High Promise has all the internals variables. We have the state, the value, and the set of callbacks there. All right? It's also got this do work function here. And the async function is the time-consuming or blocking function that my promise will wrap. Here we are simply just going to pass it the async function to the do work function. Note that I'm also passing in the context. I'll need this later to access some of the member variables of my promise. So let's taking a look closer at do work here. Things get a little fuzzy. Here the async function is called, but it's called with two functions as parameters. It becomes a little clear once I show you how High Promise will be used. The right side shows High Promise being used. The relationship I want to show you here is between the resolve function and the onResolve handler. Reject would also have a similar relationship to its handler. To understand how this relationship works, let me show you the flow of the setup. Okay. It starts at the new instant of my promise. When we construct the internal state, and then call the do work function with the async in tow, the async function in tow. The actual implementation of the async function is actually back on the right. Yeah, on the right there, when we pass it in via the constructor. After a time, the async function will then resolve the function, which sends control back to the onResolve handler inside the do work on the left-hand side. This is a typical data flow of a promise being fulfilled. A similar path occurs with a promise rejection. So it's a bit of a wiring. I know, it's a bit of a wiring, but it is just a state machine. This is all how promises changes its status from pending to fulfill. And okay, so now we know how the internal state of a promise has changed. How does the promise then notify that it is fulfilled or rejected? And that's where then comes in. Then can take two functions as parameters. The first is always resolve, the resolve handler, and the second is always the rejected handler. The then method operates depending on the current state of the promise. If pending, it simply stores the resolve and rejected in the callback list. If it say it's fulfilled, it simply calls the onResolve handler, and if it happens to be rejected, it calls the rejected handler. So on. A little weird how the public then method works, but you get the idea. Now we have a way for the outside world to work with our promise. The then method of promises is probably the most use I've seen when working with promises. Yeah, it's myself. But we're not quite done, because in the case of the pending state, we actually don't have anything set up to invoke all those callbacks. The final piece missing is this finale function. This function is called inside the resolve and rejected handler and has the job of invoking all the callbacks on its list. Of course, it operates based on whether the state is fulfilled or rejected. So that's a bit of my promise. It's 42 lines. Obviously, it's not done. There's still the missing, the public done function, as well as the rejected catch. Catch and done is not there. But I'm willing to bet that since you guys are given the state machine, you can probably implement those your own. So this type of implementation, I learned from the promise polyfill, whoever the heck is maintaining that. So, but in this case, though, it's usable as long as you're only using then. Completely usable. So let's go to an example, and I hope at this point you understand a little bit more of how promises work. It's, like I said, it's just a state machine. I find out that as I put more and more promises in my code, it becomes a little cleaner, a little easier to work with. So this is an example here where I'm just using it. However, this wasn't a complete solution to our problem with asynchronicity. I still encountered the pyramid of doom. It's very similar to callback hell. And I had issues with passing data between asynchronous function 1 into asynchronous function 2. I had to use hacks and monkey patching to just get around limitations. These hacks had terrible side effects in my functions. I talked to others around town to see how they handle theirs, and they pretty much had the same workarounds, and much like mine. I wasn't happy about the workarounds. I kept looking. I didn't want it. I just didn't want it to accept, I guess. Just too much of a perfectionist. So I looked into ES7, specifically async and await, and it seemed to be a solution to my ordeals with promises. And as with some things with JavaScript, async await seems easy to work with at first on the surface. Okay, so I found out to work with async await, I have to put I have to transform my asynchronous function there. With all I gotta do is prefix it with async. No problem. Okay, just a new keyword. You guys aren't worried. I'm not worried. I can handle that. Then I have to add in await, and I found out that await can be followed by a promise. Well, no problem. I know promises. You know promises. I put it in. I put it in all my promise, and lo and behold, it works. It works as expected. I was confused. It's like, how's this work? I was more specifically confused about the flow. Okay, how does JavaScript know to pause execution of get user authorization until get users get done? How does JavaScript know? Wait a minute, it shouldn't. In all my training of JavaScript, instructions always move from one line to the next. It's not like JavaScript hangs there in between line 2 and 3, awaiting get user to get done. I don't get it. Yeah. Now I thought maybe JavaScript breaks the rest of the login function into like a callback or something, like so. And then once get user done, JavaScript will put it back and resume normal operation. I don't know. No, that wasn't the case at all. It turns out that there were some new concepts I didn't even look into. Here's the first one, iterables. They're actually quite simple to understand. Simply speaking, the iteration protocol allows a user-defined JavaScript object, any JavaScript object, the ability to tell the JavaScript interpreter the things that will run your JavaScript. No one messes with that. Okay. Basically tells the interpreter how the object should be iterated in things like loops and mapping functions. That's a little hard to get. Tell you what, let me define one in code, and then you'll get it. Okay, again, an iterator is a JavaScript object that has a special function property called the iterator that returns an object. That return object must have a next function. That function must return another object. And finally, that object must have a done and value property. Okay, the reason why it's set up this way is because of the iteration protocol. JavaScript demands you set it up this way, or else it's going to say, I have no idea how to iterate your object. No idea. The done property there that you see is just a Boolean. It tells the JavaScript interpreter when the iteration of the object is done. There's no more data, go away, basically. The value is the current value of any one iteration. It's optional when done is true, of course. So let me add in some data, and that way I can show you what a true iterable looks like. Value simply takes the first word out of that word's array, and done, you know it's done when all the words are gone. The length is 0. Just like that. This is an iterable, ladies and gentlemen. This JavaScript object is able to be iterated, like so. Each time this for of loop runs through, it knows automatically to call the next function, which will return a value for it to use, for the loop to use. The for loop knows this because we have defined the iterable to conform to the iteration protocol. The protocol is just a rule, a set of rules. Got it? Okay, we all know what iterables are. That's good. Oh, you can also do crazy things like you can extract out the iterator and then use it manually to get one value at a time, just like that. So iterables are pretty cool, and I urge you to look, have a closer look into it. Or at least just the iteration protocol, because you might need to create a custom object one of these days and allow users to be able to iterate over it via for loop or mapping or whatever. Okay, so now that you understand iterable, the second concept you need to know before understanding ES7 async await is generators. Generators too are simple to understand once you understand iterables, because a generator is just a function that returns an iterable. Here, we declare a generator. Call the words generator. We do that using this new function star syntax. I know it's weird. That's okay. Again, just a new keyword. Shouldn't scare you guys off. Oh, the yield keyword, that might scare you guys off. So, yield is just like return. One keen, very keen difference. Yield has the power to halt execution of the generator function. That's pretty crazy. Because until yield, the only way I know how to prematurely exit out of function was to return, make a callback, even throw an error if I'm really desperate. So this is weird. This is very weird. But you can see how this could be useful in our problem with asynchronicity. Running the above code, we have the following result. No surprise here. Same result as our previous iterable example. Look, it even has the next function there that returns a value just like the iteration protocol wants it or dictates. Unlike iterables, generators allow us to be more programmatic in our control of the data. We have more control over what the data looks like and how it should be yielded. Let's look at another example. Take the example on the right here. This example will produce the exact same result in the console as before. But now, notice now how the data inside the generator is now mixed with the data outside. The flow of this logic is constantly going in and out of the generator. Never's on the inside, that gets console log out. Ghana is on the outside, that gets console log out. Then give you up, pretty much. It's weird how control just flows back in and out like so. But this is valid JavaScript. Cameron's just laughing because he loves this song. One of the best on the internet. So we can even do more crazier stuff with generators. Suppose you have a database schema that requires a usage of a natural number as IDs. Here's an ID generator for you. It's kind of weird. Seems like an infinite loop there. But really, each time, imagine just an infinite lines of yields. Yep. As far as the eye can see. That's basically what I'm creating. Just an infinite line of yields all the way down. Will this yield ever get done? I mean, will this generator ever get done generating? No. No. Because every time you call next, it will give you the next value into infinity. Something will break, I'm sure. But, you know, who cares about that? That's for the other guy to worry about. There are more generators, but that's enough to understand and move on to the main topic of this talk. So let's look back at a sample async and await function. Here it is. It turns out this is not the real form of an asynchronous function. Async is really just syntactic trigger over generators and promises. Here's what async and await looks like behind the scene. We'll get into what Spawn does later in a second, but as you can see, the async keyword is just syntax trigger over the generators, this generator setup. And await is just syntax trigger for you. So really, this talk should have been titled ES7, asynchronous syntactic sugar over promises and generator. And it's true, until async and await is implemented natively in browsers, they are just syntax sugar. And that's why I had to show you promises, iterables, and generators first. So let's turn our focus back in the innards of async and examine the spawn function. This is where it gets really hairy. Bear with me. First, I'm not surprised that spawn returns a promise because I already know that you can put await in front of your async function and everything will work just fine. So this should tell you something. It should tell you that it's possible to call the async function, which I'm sure you guys will make after this. You can call it synchronously or asynchronously. You put await in front there, you make it synchronous. You take it away, it's asynchronous. I hope I got that right, or it's backwards. Yeah, I'm sure it's right. Okay, so now let's look at the work function of the promise. Somewhere in here, we should see a resolve and reject. There it is. We'll come back to this later. Right now, I want to see how this work function is actually working. Okay, let's go to the very top of the function. Okay, looks like the first thing this work function does is call the pass-in generator function. No problem. The generator object return is then wrapped in this anonymous function and pass into a function called step. What step represents is each of the yielding step of the generator function. So you can imagine if you have, 10 yields, you'll have this will run through 10 times. It's actually 11, but we'll get to that. For simplicity, I only have one step. It's just get user. That's it. Okay, then the result of this the whole weird anonymous next function is checked. And there's really no other, if there are no other steps to do, the work function resolves the next value and returns. However, if there are additional steps, then it wraps it around, it wraps the next dot value around promise.resolve. I didn't introduce you promise.resolve. But basically what it is, it's not the same as the resolve callback. Promise.resolve takes a value or a promise. If it is a promise, promise.resolve will wait for the promise to get done, then invokes the promise appropriately. So it's just an implementation that I didn't show you. That was not on our original model, wasn't in my high promise, and so on. The whole bottom part there is one small link in the promise change. Next.value at this point is whatever is returned from getUser, which is a promise. And promise.resolve will wait for getUser, for the getUser promise to get done before invoking the next step. So that's why you have that then there. This is really hard to wrap your hands around. You might have to like just run through this a few times. This is where the magic of making that whole slew of asynchronous call synchronous. Just one step right after another. Of course, there's also the code in Spawn to handle cases if one of the steps throws an error. Okay, so to really solidify your understanding of generators and props, I mean async and await, I want to take you to a typical flow. It starts at the login function. It enters spawn. After some time, flow jumps into the promise work function. You have to trust me, after some time it does jump into it. The work function sets up and calls the generator and calls the generator, which returns the generator object, which then jumps back into the login function to call getUser. GetUser will return a promise, not the user data. GetUser's asynchronous operation is not yet done. Control is then given back to the work function. The next value makes it all the way down to the bottom. Now, this is where promise.resolve will allow getUser to carry out its asynchronous operation. And after that gets done, the step function is recursively called and the cycle starts again. But the second iteration of yields no value. It's just done is true, and we resolve, and that's it. Here's the entire flow. It's a bit to digest, I know. It's not actually my implementation. In fact, I have long forgotten where I got this. It's yeah, I have no idea. But regardless, if you type up this code in Node, the code will work, and the result is a linear workflow. And that is the end of my story. Any questions? You guys gonna start using async await, or probably gonna have to research a whole bunch before we do? Yeah, what's up?
So, how can you, does that run all three of those async applications?
No, it's one after another. Because if
How would you achieve running them?
in parallel, there are just like Promise has .all. There is you can combine literally all those promises operation in promise.all and do an await on that. So your syntax would be await promise.all and then all of your promises. if you want parallelism. So yes, there are definitely, one of the mistakes in using async await is not respecting parallelism. You have to realize that not every asynchronous function has to be run one right after the other. Now, if you need data from one to the other, yeah, definitely. Because obviously I set up my strategy so that way. Where is it? I set up my strategy so that way I have to have the user first before I'm able to get its authorization. And I could do things like pass in the user in the authorization method. And authorization and meetup profile can probably ran at the same time. That probably wouldn't have interfered, but this was just a demo. I didn't really put too much thought into it. Any other questions? Good one.
I have another question.
Yeah.
If you are writing a function login, you await something, do you have to make that function async?
Yes. It actually will throw you an error because it won't know what async is. I mean, what await is. Any function that you designate as an asynchronous function has to have that async in front. If you simply just say, now await is slightly special. It can be put in front of any promise, and it'll be just fine. If promise or value, it'll be just fine. But the problem is await requires to be put in an async function. So they're kind of dependent on each other. You can't break this dependency. Cameron?
So, I'm very good with JavaScript. This is exactly the same as the Python's implementation.
Good.
Word to word. But there's one fatal flaw with Python, which is that if you do anything the same, you basically do anything the same. Is that true here? Or
Not necessarily.
or
Like,
can I just throw async around anywhere I want and still have blocking calls?
no. Well, if you want to call an async function synchronously, you would just it's the difference between calling login or await login. So yeah, if you call login, that is a fire off and forget. You will not know where that goes. But the problem is, if you are dependent on anything that login provides, everything below will break. So when you call login, I got to get my term correctly. Synchronously? No, that would be if you call login asynchronously, it would be without the await. Yes. And if you want to call it synchronously, you put the await in. Like you have to. I know that's stupid and confusing.
Does that mean you get a promise out of login if you don't use await?
You do, yes. Wait, say that again. Whether you get a promise out of login if you use await. I think you get a promise either way.
Await calls the next on yield.
Say again?
Await is actually called next on.
Yes.
So what that actually mean? It's not going to be called next. Await is actually next.
And the await doesn't call next. Yield does, but I see what you're saying. They are kind of the same. You know what? I think you got me confused on that.
I think it sounds like it.
Yeah, a lot of practice I found out just learning is just putting in some console log to see where the flow goes. It goes everywhere. It's a freaking mess. Just like whoever. I mean, I can see how this conclusion was contrived, but I really just benefit from the final product. All I have to do is just put an async await, and I already know how this thing works. The problem I run into is stupid stuff, like I forget to put an await on something, and I didn't realize that. Say, for example, if I forget to put await on get user, and just run that as it is, then when it comes to what it will do is it will run the line 2 right away, fires it off, and that's an asynchronous operation going on, spinning off to the side. And it goes immediately to get user, and it waits for that, and that fires off the asynchronous operation as well, but it errors out and says, oh, I can't find user. And then I'm debugging through the whole thing. It's like, why? I told you to go get the user on line 2 and then go get the authorization on line 3. What's the matter with you? So I just get tripped up, and just because I forget on that. So asynchronous operation can be a little tricky at times, but you can tame it with async and await. Yes, sir?
Does async await play well with observables?
I do not know observable well, so someone else can probably answer that question. Did I have another question? No? It was a short one. It was a short one. So that's why I wanted to know. Anyone else? Anything at all? Any more confusions to clear out? Oh no, Jared.
Are you ever going to give up camera?
No. No.
Thanks, Si. You hang out afterwards? All right, guys. Those of you that are new, we typically hang out afterwards at Psalms next door.